Okay, this video will deal with the other two p orbitals. Again, here's my drawing of my atom with, this is, the Y is typically here, and the X typically goes out back behind the board. That's a terrible drawing, but let me color it in. Again, it doesn't matter what colors you use. Alright, so there they are. Now I need to talk about the overlap of, I'm going to talk of PY. The PX is exactly the same, only 90 degrees out. So here's our two atoms, and here's our p orbitals. I exaggerate a bit with my p orbitals, and I'm bringing them close together so that they overlap like that. Okay, the orbital drawings are a little bit exaggerated, but I have to do that so you can see what's happening. Alright, so here's our orbitals. I'll draw orange and blue. Oops, I lost an orbital there. Blue for this orbital and orange for this side of the orbital. So one orbital here, one orbital here. Remember, the orbital looks like it. That's an entire orbital. So when I add them together, again, they're going to drop in energy, and I'm going to get overlap right here and right here. So I end up with something that looks like this. Notice it goes to 0 here, and it goes to 0 here. We don't have any orbital there on the bond axes. So on the bottom, I overlapped them, and they're blue. On the top, I overlapped them, and they're orange. And this is called a pi bond. Pi bonds are always off axis. Here's the bond axis, and there's no electron density on the bond axis. That's where they get the pi symbol for that. Okay, so that's a typical pi bond. If I go and subtract them, let me redraw. Okay, there's the redrawn orbital. In this area, right here, they're going to cancel. Okay, so we got canceling in two places. So my orbital is going to look something like this. And I just kind of go like that for the one, and the other one is going to go like this. So notice we're canceling in the middle, so I have no bond density through here. Okay, and this is called a pi anti-bonding. So we use pi star for that. Oops. Use pi star for that. Okay, and we color them. This one I'll leave the same, blue and orange, and this one's flipped, orange and blue. We only ever use two colors. That indicates that they canceled in the middle. This is called a pi star molecular orbital. So we have a molecular orbital here. That's one orbital. That's the pi star. Down here we have the pi bonding orbital, or just the pi bond. This is anti-bonding because it canceled. Notice the bond axes, we have no electron density on there. Hence it's called a pi bond in both cases.